hello everyone, welcome to the knowledge session. And here, me and Gaurav Srivastava will talk about Kafka connector. So, before diving into the session, let's just quickly discuss knowledge etiquettes. So, the first one is punctuality. So, it always recommended to everyone to join the session at least 5 minutes before. So, it gets started on time. And and the next is please keep your window on mute until you have any session. And if you have any question, you can just unmute yourself and ask the question. And third is please avoid disturbance. So after asking a question, please don't keep your windows unmuted so that we don't get distracted. And the last one is please make sure you submit constructive feedback because it's always helpful for the presenter to present you better from the next time. So that was the knowledge etiquettes. Now, let's quickly discuss the agenda of the session. So first we will see what is Kafka Connect. Then we will discuss different types of Kafka Connect. And after that, we will also understand the architecture of Kafka Connect and how does it work and what are the concepts. And we will see Kafka Connect on a high level as well. And we will see we'll understand the use cases of Kafka Connect and features of Kafka Connect. And then we will wrap up the session with the demo. So let's first see what is Kafka Connect. So Apache Kafka is a distributed streaming platform, and Kafka is a framework for connecting Kafka with external systems like databases, key value stores, search indexes, file systems by using connectors. And Kafka connectors are ready to use components which help us to import data from external systems like Kafka topics and export data from Kafka topics into external systems. So in simple word, we can say Kafka is a distributed scale fault tolerant service designed to reliably stream data between Kafka and other data systems. And data is produced from a source and consumed to a sink. So the question must be raised like, what is source and sink? So let's understand. Um, there are two different types of Kafka connector. The first is source, another is sink. The source connectors collects data from system, and source connectors can be entire database, stream tables, or message broker. And source connectors could also be collect metrics from application server like Kafka topics and making the data available for stream processing with low latency. And now understand sync connector. A sync connector delivers data from Kafka topics into another system, which might be indexes such as Elasticsearch, batch systems such as Hadoop, or any kind of databases. In simple word, we can say sync connector uh, sync connector read from Kafka and sync to target, and source connector read from data sources and write to Kafka. Another option is we can use existing connector implementation for common data sources and sync, or we can implement our own connectors. These are the options. We can implement our own connectors, or you can use the existing one. So next slide. Now the question, a very important slide is, please pay attention. Uh, the very important slide is like how Kafka Connect work. So Kafka developer made a very smart decision and create a framework named as Kafka Connect framework, which is very popular. Kafka Connect framework allow you to write connectors, and these connectors can be of two types: source connector and sync connector. The Kafka Connect framework takes care of all the heavy lifting, scalability, fault tolerance, error handling, and bunch of other things. As a Connect developer, all we need to do is to implement two Java classes. The first one is source connector and sync connector class, and second one is source task and sync task. Once your connector is developed and tested, package it and share with others, and they could able to use it. It was as simple as that. Suppose take an example. Assume you want to bring some data from RDMS to Kafka cluster. All you need to do is to take a appropriate source connector, for example, a JDBC source connector. Then you install it to a Kafka Connect and configure it and then run it. And that's all. There's nothing more to do. You just need to choose a best connector for your purpose. And all the JDBC connector, the one you have chosen, the JDBC connector will take care of the rest of things. Similarly, when you wanted to move data from Kafka connector to suppose Snowflake databases, any databases, get the that get a proper sync connector, install it in your Kafka Connect, configure it, do some configuration on basis of requirement, and then run it. And your task will be done. I hope this slide was helpful to understand the why it is the most important thing. So now discuss the architecture of Kafka Connect. To learn the architecture of Kafka Connect, you have to understand a few things like worker, task, and connectors. So let's first understand the core concept, and then we will come back to the slide to understand the architecture. So first, we'll see connectors. So Kafka Connect cluster has multiple loaded connectors, and each connector is usual piece of code. It is basically a Java jar, and connector used to cooperate and manage the copying of data between Kafka and between the Kafka and other systems. And next one is task. It does the actual implementation of copying a data to or from the Apache Kafka. Each instance of connector coordinates a set of tasks which actually copies the data of the data, and connector is able to break a single job into multiple tasks. This provides built-in support for copying data parallelly and scalably with the little configuration. Next one is workers. So the tasks are executed by Kafka Connect worker and Kafka Connect worker or server, and worker takes these tasks and execute them. Worker is a single Java process, and it can be in standard mode or in distributed mode. We will see in the next slide what is standard mode or what is in distributed mode. For now, a worker is a single Java process, and it can be work in both mode. And the next one is transforms. It is used to alter the data to make it simple and lightweight. It is just a simple function which makes a single record as input and modifies it and output the record. Kafka can provides a number of transformation, and they perform simple and useful modifications for us. And converters, it is the code. It is mainly the code which is used to convert the data between Kafka Connect and the sender receiver. These converters are used by the task to change the data format from bytes to Kafka Connect internal data. So as you have understood the core concepts, now coming back to the last slide, architecture. Kafka Connect is a separate cluster, and within the Kafka Connect cluster, there are workers, connector plugins, connectors, and tasks. I think this diagram is self-explanatory. Everything is saying. So Kafka Connect clusters can have one or more workers, and these workers are fault tolerant, and they use the group ID from the cluster. And the group ID mechanism is the same as Kafka consumer ID. So all you need to do is to start the worker with the same group ID. The work the worker works like a container process and will be responsible for starting and running the connector and the task. These workers are fully fault tolerant and self-managed. It means if the worker process stop or crash, die, another worker in a cluster recognize that and reassign the connector and task that we ran on that previous worker in to the remaining worker. If the new worker join in the cluster, other worker will notice that and assign connector and task to it. And all those workers run on a cluster. Next slide. Yeah, I was talking about this slide. Here we'll understand the difference between standalone mode or distributed mode. So we have two ways of running Kafka worker, either in standard or in distributed mode. So standard mode, we understand standard mode first. Basically a single process, a single worker to run both connectors and tasks. And configuration is bundled with your process, and it is very easy to get started with and very super useful for development and testing. It's not fault tolerant. If the process fail or die, then you left without connector. It doesn't scale horizontally at least, and it is very hard to monitor. So in distributed mode, you have multiple workers to run connectors and tasks, and configuration is not bundled with the workers as in a standard mode. It is submitted using a REST API, and it is very easy to scale, just opposite of standard mode, and fault tolerant. And you get fault tolerant, you get horizontal scalability as well, which was not provided by the standard mode. And all of that makes very useful, which makes very useful for production deployments of connectors. So main difference between standalone mode or distributed mode is like standalone mode is useful for development and testing, and distributed mode for production deployments of connectors. So we will first understand distributor architecture in details, why this is very useful and how it is fault tolerance and it has scalability and all that. In this slide, we will learn distributed architecture with a lots of details. We have a Kafka Connect cluster and we have a multiple worker, as we can see. And remember, each worker is a process, and usually that process is an entire server. First connector is made of 3 tasks: test 1, test 2, test 3, and as you can see, they are spread among the workers. And so worker 1, worker 3, and worker 4. It is just an example. And our second connector, it can be a source connector, it can be a source connector, it can be a sync connector again, and has 2 tasks, task 1 and task 2. And in our third connector, it could be a sync connector. It has a 4 tasks. That it has as you can see, in each of the tests are run on each worker: worker 1, worker 2, worker 3, worker 4. So, so now something happens and your worker number 4 dies, the left one, worker 4 died, and server just crash. Suppose server just crashes or you lose that network. Something happened. In that case, our connector number one, the task number 3 from worker 4 gets moved to worker 2. And similarly, our connector 3, the task 4, get moved to worker 1, where 1 is now doing the task related to connector 3. So you can have multiple tasks of the same connector on the same worker. So as we can see the right here, when you have distributed architecture and you have a worker that dies, you just have to rebalance. And that rebalance allow your cluster to basically keep on doing what it's supposed to be doing. And that's really awesome, because that means that you can have fault tolerance architecture. If you lose a server, well, your Kafka cluster will just rebalance and everything will be fine. So it's pretty awesome. So I wanted to explain on this from architecture diagram, that while running stuff in distributed mode is so much better than single mode, because if you just stand on mode and you lose your server, there is nothing you can do, everything is gone. But here within a cluster, if you lose a server, then one will pick it up and your connector will still work. The diagram is explaining that as well. So we have seen the principle of Kafka Connect, little bit theory, and now we will understand Kafka Connect high level. Just to summarize all that. So source connector is used to get data from common data sources, and sync connector is used to publish that data in common data store. It is a part of ETL pipeline, and it makes it very easy for non-experienced devs just like us to quickly get data reliably into Kafka. And most important, the code is reusable. So the only thing that changes from one connector to someone else connector will be the configuration. Kafka Connect use cases. Kafka Connect is generally used for streaming data pipelines, and Kafka Connect connectors is designed for connecting Kafka with other data systems. With the help of Kafka Connect, you can process data from outdated application to a new systems. These are the features of Kafka Connect. The first one is common framework. It works as a common framework for Kafka connectors, as it is a framework for connecting external system with Kafka and Kafka with the external systems. It simplifies the development, deployment, and management of connectors. And second one is it can work in standalone or as in distributed mode. It was completely optional and on basis of your requirement. And third one is it has a feature of REST interfaces on distributed mode, as we can submit or manage Kafka connector to the Kafka Connect by REST API. And by default, Kafka Connect is scalable and distributed. Thus, the number of workers can be extended for scaling purpose. And it also has the feature of automatic offset management, as the Kafka Connect is able to manage the commit process automatically by getting a little information from the connectors. And Kafka connector is ideal solution for bridging streaming and batch data system. Yeah, these were the features of Kafka Connect. And now Gaurav Srivastava will take the demo part.
Okay, thank you, Anuradha, for explaining the Kappa connector. Now let's move on to demo part. For that, let me share my screen. Anuradha, can you please close your screen?
Yeah.
Yeah, thank you. So let me share my screen. Please let me know if my screen is visible. Can you please confirm, guys, like my screen is visible or not?
Yes, Gaurav, it is visible.
Yes, it is visible.
Okay, thank you. So now I'm going to launch Kafka connector, and for that we are using Docker and Docker Compose. So the first step that you need to install Java, because as you can see in my system, as I already downloaded Java and installed Java. If you don't have Java, then you need to install Java first. And let me explain the file. As you can see here, the file is Docker Compose file. And second step, your system must have the Docker and Docker Compose, because we are using Docker container here. So this is a Docker compose.yml file. Here you can see this, with the help of this file, we can launch the Kafka cluster. As you can see, we are using image like land loop image. So why we are using this image? Because this image already had lots of connector present. So we are using for practicing the connector. And as you can see, there are lots of hosts as well. Like as you can see, the 127. This is our main server, where once we launch this file, then our server will run on this port. And you can see there are lots of port for accessing different features as well, like 2181 for Zookeeper, 3030 for Landloop UI, and 8081 for REST proxy, and 9092 for Kafka broker. And the further code is for the backend. Like as you can see, if you want to add our backend part, like if you want to add the database, so you need a Postgres. So in this way you can configure your database as well. So but for today we are only focusing on the Kappa cluster part. So we are not focusing the database. So first let's try to run this file. So I will explain all the things. So for that we are using command line docker compose of Kappa cluster. So once you hit the command, so this will download some files in your system, and it will take some times like to running the command. Yeah, so as you can see, uh, once the code is run, so as you can see, my server is running on the host 127. As you can see, we declare in the port here. Sorry, this port. So my server is running on same port 127.0.0.01. So if we click the file, so yeah, here you can see we are getting the Kappa development environment UI, and we are running the Landop UI because we are accessing the port 3030. As you can see, we already mentioned in the page, we are accessing for 303. We can use Landop UI, right? So this UI will take some times to load. So just wait for 2 or 3 seconds. I will explain you the other part as well. Like you can see the schema is present on here, like all the schema. And once you go to the topics, as you can see, all the topics are present here. Whenever you create a topic, so all the topics are listed here. You can go inside and check if anything is present, if any data is present or not. So as you can see, right now this topic is empty. So I think it will 1 or 2 minutes. Let me refresh it. I don't know why it's taking too long. So yeah, once you open this UI, so it will take around 1 or 2 minutes to load the connectors. It's taking too much time. Yeah, so you can see my connector is running, one connector is running, as you can see here. If you go inside the connectors, so we can see that my one connector is running, the Kafka that we created earlier. And if you click the new button, you can see all the connector present that you can use according to your needs. So now next we are going to create one standalone topics for the Kafka cluster. So let me create a new terminal here. Sorry, my screen is paused. Hello, I'm audible.
Yes, bro.
Yes, Gaurav, you're audible.
Okay. So, uh, so now we are going to create one topic here. So for that we are using command like docker run tutorial. So this command will help you to mount all the file into tutorial folders. So let me show you the folder as well. So as you can see the tutorial folder present. So let me go inside tutorial folder. So if you click the ls button, so as you can see all the files are present in the tutorial folders as well. So now let's go back to the root folder because where we need to create our topics. So yeah, we are in the we are in the root folder. So this is the command for creating the topics. Once you click enter, so yeah, it's showing like the standalone topic already created. So let me change the file name, topic name. So we can pass say something. So let me explain this command as well. So this is the Kafka topic that we are creating. Create is a command, and topic demo 7 standalone is the name of the topics, and we are creating the partition here for the topics, and we are telling that this zookeeper is running on the same port. So once we click enter, so we can see the topic is created, as you can see. So let's go to the UI part where we can see the topic is present or not. So as you can see, my new topic is added here. So as you let me show you the name. We added demo 7 standalone. So if you go to the topics, so you can see there's a standalone topics created. So in this way, we can create a topics and we can add data as well. Uh, so yeah, that's all for the demo, guys. If you have any questions, so please let us